Before moving on to example 2, we have to take a look at what quartiles are. The first thing that we need to look at to do that is the median. The median of a set of data is the middle piece of data. When you order your data from least to greatest, it is the midpoint of your data. If you have an odd amount of pieces of data in your set, there's going to be one middle number, so that would be your median. And if there is an even amount of numbers in your data set, you would find the average of the two middle numbers, and that would be your median. In this set we have 12 data values. We're going to organize the data from least to greatest, and we are going to look at the 6th and 7th numbers. Those would be our two middle numbers. So looking at this data set moving from left to right, if you count off the first 6 numbers, that would take you to 28. And the 7th number would be 30, so we're going to find the average between 28 and 30. We do that by adding up 28 and 30 and dividing by 2, and that gives us 29 as our median. Once you find your median, that splits the data in half. You have a lower half of data, and you have an upper half of data that gets split by the median. You could also look at the median as splitting the data into two 50% chunks. You have a lower 50% or an upper 50%. The next thing that we're going to do is find the median of the lower half and the median of the upper half. Both halves of data have an equal amount of numbers, so we're going to take the average of the two middle numbers. In the lower half, that gives us 17 plus 21 divided by 2, and in the upper half, that gives us 38 plus 44 divided by 2. The lower half, we end up with 19. For the upper half, we end up with 41. When you find the median, and then the median of the lower half and the upper half, you found 3 total medians, and this splits the data into 25% chunks. These 3 medians are your quartiles. The median of the lower half of data is known as your first quartile or your lower quartile. The median is your second quartile, and the median of the upper half of data is your third quartile or your upper quartile. These quartiles allow us to look at data in quarters, or 25% pieces. Looking at this example, we're going to try and get a better idea of what the quartiles actually represent. We're given the math scores of 600 students on a standardized test that have been put in order. The quartiles are given for us. Quartile 1, or the first quartile, is 380. The second quartile, or your median, is 466, and the third quartile is 547. I'm going to represent these quartiles with a visual here that shows each 25% piece. Using this visualization, we're going to make some generalizations about our data set. And again, our data set represented the scores of 600 students on a standardized test. What these quartiles allow us to do is visualize the data into 4 sections. You have 4 25% sections, and in this situation there were 600 students that took the test, so each section is represented by 125 test scores. Based on this data, we can make these generalizations. We could say that 25% of the students scored less than or equal to 380 on the test. We could also say that 50% of the students scored less than or equal to 466 on the test. Or we can say that 75% of the students scored less than or equal to 547 on the test. We could also say the opposite about all of these. The first one was that 25% of the students scored less than or equal to 380 on the test. That means that 75% of the students scored more than or equal to 380 on the test. In this example, we had a number that was divisible by 4. So in every situation, we could say 25%, 50%, or 75%. If you end up with a data set that is not divisible by 4, then we would say about 25% or about 75%. So there's a little difference in the wording there depending on how many pieces of data that you have in your set. Example 2 is going to give us a scenario where the amount of data is not divisible by 4.